Good morning, I'm Andy Aspden from the School of Engineering at Newcastle, and I'm going to talk about how we've implemented the Numbas system in our first year Thermofluids module. It's a fundamentally engineering module, but it's mostly numerical, and so it's well suited to the Numbas system. We deliver the module to the cohort as a whole, so we have 400 or 500 engineers. They're mechanical, civil, electrical, marine. As a consequence, and due to the high numerical content, a lot of the students find it quite challenging. We deliver the module over the course of the year. We have short weekly recordings so they can watch before they come to a problem class where we go through examples of the problems. There's a weekly tutorial where PhD students will help them with any questions they have, and then we have some experimental labs scattered across the year. We rely heavily on the Numbas system. We use it for tutorials and lab sheets and all of the assessments. While most of what we do in Numbas is quite conventional, there are some interesting things, in particular how to use property tables and how we've implemented the lab sheets. We have 3 assessments across the year. In semester 1 there's a formative assessment so that they can get used to the system. Semester 2 there's a summative in-course assessment that follows the same style as the semester 1. And then we have an end-of-year exam. We release the in-course assessment round about the time of the first tutorial sheet, and it then remains available until the deadline at the end of the semester. They get 1 set of questions, but they can come and go as often as they like. The questions are taken straight from the tutorial sheets, where there are worked solutions, so if they can identify the question, that solution will help them complete the in-course assessment. The idea is that it's low stakes, low stress, takes about 10 or 15 minutes a week, and designed to offer easy marks in exchange for engagement. The end-of-year exam is in person, online, in an invigilated room, and covers the entire syllabus. It's a similar style to the tutorial sheets, but the questions are unseen. It's partially open book, so they can have access to all the teaching materials for the module, and they can take 2 pages of their own notes. So the tutorial sheets are straightforward. They're simple questions based on the lecture material. Here they can have as many attempts as they like. The numbers are always randomized, and so they can use these for practice. There are detailed work solutions for all questions, and those solutions use the randomized numbers provided. With the lab sheets, the idea is that it can take the students through the whole experience. There are instructions, including the health and safety, about how to conduct the lab, how to collect the data, how to do the calculations. And the way we've done this is to exploit the explore mode style question to move from data collection and calculations and graph plotting, and combine these questions to make up a whole lab sheet. So here we have an example of a tutorial sheet question. We include nice diagrams. We provide data for the questions, and this is a standard cycle question. The idea is that they calculate individual processes and can calculate the thermal efficiency of the cycle. So it's a quite involved question, so the way we've delivered the work solutions in this case is to include them as steps. So each part has a hint that they can use as they work their way through the question if needed. Now, one of the things we use a lot are these property tables. So tables and tables of numbers that describe the properties of fluids at different conditions, pressures, temperatures, etc. So incorporating these took a little bit of work, and one of the things I'd like to talk about. So here we have a question about superheated steam, and we're asked to find the specific volume at a set of conditions. It's a double interpolation problem that requires looking at properties of fluids in those tables. So to have randomized numbers that rely on the tables took a little bit of work. And here we can see work solutions using those numbers that were found in the property tables. The way we did that was to create lists and the variables based on the property tables, where we have 7 pressures, and then what are effectively 2-dimensional arrays of temperatures. We then use random numbers to generate the index for pressure, temperature, and then a fraction between the two, and then we can look up the values of pressure in the list using that index and temperature with a two-dimensional reference. We first copied the property tables into a spreadsheet, as this made it much simpler to copy-paste the relevant numbers into a numbers list. For the lab sheets, this is an exam. Each one of these questions takes the students through a different piece. So here we have instructions with diagrams labeling the different pieces of the kit. Further instructions about health and safety and how to collect the data. Here I've completed the tables already, and then as we submit, then we get this option to plot a graph. Here we can see there are data points that are clearly broken, so we can go back and amend these numbers. So here I've missed a digit, here I've missed a decimal place. I can resubmit these numbers and replot the graph with the data, and we can see how the experimental data in the blue dots compare with the values that are looked up from a table with another set of data that we've provided as reference. Here we have a more substantial lab sheet. In this case, we have different questions that take them through health and safety with a little more care, including multiple choice. We also use the explore mode again to go through different pieces of the kit. And then we come on to data collection. We explain the experimental procedure. And again, I've pre-completed the table. We enter all these numbers. We click submit. And now we can move on to some calculations. There are explanations about how to calculate each piece, and then a table of numbers based on their data. Now this data has followed through from their collection table, and then using the adaptive marking we can use their numbers for their calculations. There's an example of how to perform one of the calculations if they get stuck, and an example graph so they don't have to complete everything to be able to look at their data. A lot of this has worked quite well. The students have provided positive feedback. They find the number system easy to use, and they particularly like the worked solutions in the tutorial sheets. The lab sheets have also proved popular, both with students and technicians. The in-course assessment works well with those students that engage and provides good preparation for the end-of-year exam. The end-of-year exam itself deals well with a large cohort for a substantial piece of work. Now that the exam schools are used to the system, we actually had 0 paper scripts to mark this year. We're now at a stage where the module is running well and requires little year-to-year maintenance. Ultimately, Numbas has enabled a better experience for everybody. The main thing we've struggled with is engagement. So the way we set up the assessment, everything that counted was at the end of the year. And so there was a tendency for students to focus their attention elsewhere and come back to this module at the end. For next year, we've broken this down into smaller chunks. We'll have more deadlines, breaking up each piece. There's still a formative assessment so they can get used to the system. And hopefully by having more deadlines throughout the year, we'll encourage better engagement. We've also added the lab sheets into the assessment, so we will include a small set of questions based on the lab that will contribute to the module mark. We've done this in such a way that if they have extenuating circumstances, they can be exempted from these small assessments, so any 3 from 6. And so the hope is that we will improve engagement next year and therefore student attainment.